Good morning, everybody. I'm going to start the next section, 28.3. It's the last one we'll be doing this chapter. We'll start to review next week for the test, which I think it's on Thursday. Let me check to make sure. Yes, we'll have the test on Thursday next week, so we'll review all next week for the test on Thursday. Then we'll start to review for the final exam the week after that. So today for 28.3, we're going to look at how organ systems interact with each other in the body and how they maintain homeostasis. So the various systems in the body interact together to maintain homeostasis. So we looked at the systems the other day, 28.1, the immune system, the circulatory system that pumps blood through the body, the respiratory system that moves oxygen into the lungs and carbon dioxide out of the body. So these various systems all work together to maintain the right levels of nutrients, of water, of electrolytes, and keep out toxins and bacteria that can harm the body. Now, each organ system affects other organ systems. They're all connected together. They all have their own jobs to do, but those jobs interact together with their systems for the whole body. It's kind of like using this picture right here, a pit crew, where they all have their own job to do, but as a whole, they work together to maintain the car. And if one of these pit crew members didn't do their job, the car wouldn't operate properly. Maybe the tire wouldn't be changed. And it's just like that in the body. Organ systems work together to keep the organism healthy. If one system fails in the body suffers. So you already wrote down this bullet point up here, so you don't need to write that down again. But you should know this diagram right here. You don't need to draw the picture, but you should know these steps right here. So I would write these down. You can paraphrase these. You don't need to write it down word for word, but know the main ideas of each of these. We're gonna go through them. But you should know these 4 steps of vitamin D production. So for step 1 up here, UV light that comes from the sun goes into the skin. And below the skin, there's a compound that will produce vitamin D when the sunlight hits the skin. It's not active though. So when UV light hits the skin, it makes a vitamin D compound, but the body can't use it yet. It then goes to the bloodstream. So the inactive vitamin D goes into the bloodstream. Eventually it goes to the liver right here. And the liver will change it to another compound. It's intermediate compound between inactive vitamin D and active vitamin D. That intermediate compound is then carried to the kidneys. You have 2 kidneys on the other side of the body right here. And the kidneys convert it into vitamin D that's active. And at that point, it goes in the bloodstream throughout the body. And active vitamin D, along with hormones, regulates the amount of calcium and phosphorus needed for bone development. So when vitamin D is active now, it's able to move calcium where it's needed through the body. Your bones store calcium and phosphorus until it's needed, and then it comes out of the bone into the bloodstream. So there's this balance between calcium that's stored in the blood and stored in your blood and also in your bones. And so it goes in between being in your bones and being in your blood. If there's too much in your blood, your bones become weak. If there's too much in your bones, then your muscles can't work properly. You need calcium for muscle movement. So if calcium stays in your bones, it doesn't go into your bloodstream and into your muscles, you're not able to move your muscles very well. So there has to be this balance between calcium being stored in your blood and in your bone. And if there's out of balance, you won't be able to move properly with your muscles or your bones become very weak. So vitamin D is a very important compound, and usually it's taken together with calcium. We know that calcium builds up bone, but without vitamin D, you can't get the calcium. And so if you were to take just calcium, you couldn't get the calcium without vitamin D present. And so it'd be useless to your body without vitamin D. And that's why a lot of times you're going to see vitamin D along with calcium. In milk, for example, you'll see that they add vitamin D along with calcium to the milk, because just having calcium on its own isn't very helpful to you. You need vitamin D to carry the calcium into your body. So this illustrates that organ systems work together to produce vitamin D. You have various organs, the liver, the kidneys, the blood system, all working together to produce vitamin D and bring it to where it needs to go. This next bullet point right here, if you already wrote this down in the diagram, you don't need to write it down again, but just know that vitamin D helps the body absorb calcium and phosphorus. So it takes calcium and phosphorus from the bloodstream to the bones and back and forth. And both calcium and phosphorus are important for bone growth and strength. They are minerals that build up the bone. They're the main components that make the bone strong and stone-like. So vitamin D is a very important mineral, or very important vitamin. You get a lot of it from the sun. So people who live up north, in places without very much sun or weak sun, need to take supplements. They need to make sure they get vitamin D in their diet to counteract the lack of vitamin D they get from the sun. And down here in Texas, we get a good amount of sunlight. So vitamin D deficiency is not a very widespread problem down here in Texas. But even still, sunlight's very important. Vitamin D, if you have too little of it, besides just having calcium and phosphorus levels go down, you also will have low energy. Depression is very common with low vitamin D. So vitamin D helps energy levels, it helps your mood, helps your body function properly, makes you have strong bones. Another thing to go through today is thermoregulation, and it's a process that maintains steady body temperature. So this shows you right here, we'll start at this bottom left corner. You don't need to write down everything on here word for word, but you should know the main ideas on here. And we'll go through the main ideas. You don't need to draw the pictures either, but just know the main things that are happening here. We'll go through them step by step. So over here, the first step on the left-hand side, your body temperature is too high, and there's a stimulus that tells your body it's too hot. And that stimulus goes to the brain, into the hypothalamus. And that's your thermostat. And so the hypothalamus decides what temperature you should be at. And an impulse goes to the hypothalamus when you're too hot, telling it that the body is too hot. And at that point, it will act. It'll make a message to go out to your blood vessels and into your sweat glands. It makes your blood vessels dilate and get larger. You carry a lot of heat in your blood. And the hypothalamus tells the body to increase your blood vessel diameter to move the heat from the blood out of your body. That's why when you get hot, you're going to have red skin. Your skin appears to be red because the blood vessels are going near the surface and getting bigger. And that helps move heat out of the body. What you also see in here is sweat glands are activated. And with perspiration on the surface of the skin, evaporation happens, which is a cooling process. Evaporation carries heat off the body as well. And over time, the body cools down, and the brain is told that. And the hypothalamus learns the body has cooled down to the right levels, and it shuts off sweat glands, and it makes the blood vessels go back to the normal size. So that's the cooling process in the body. There's also another process that takes place if you're too cold. So down here on the upper left-hand side, if you're too cold, a stimulus goes to the hypothalamus again, telling it that it's cold. And it decides to activate the blood vessels and makes them constrict. So in this case, it wants to hold on to the body heat. So it makes the vessels get smaller to hold on to the blood better. The vessels go below the skin surface, and that's why you look pale when you're cold, because the blood has left the surface of the skin and gone down deeper into the body. And that allows the blood to keep the heat better and not lose the heat as quickly. Muscles start to be activated too. You start to shiver. Muscles are a good source of heat in your body, and when they move, they generate a lot of heat. So by moving your muscles, you can warm up pretty quickly. So those two things are activated when you're too cold. And again, as you warm up, a message goes to the hypothalamus telling it that it's warming up. And eventually it shuts off these two things as you get to the right temperature again. So homeostasis, again, is maintaining the right levels of temperature, of nutrients, fluid in your body. If it's disruptive, if you don't have the right amounts of things in your body, it can be very harmful. And there's several reasons why it might fail and why you might have an imbalance in your body that's not corrected. You could have failed sensors in your body. So there are certain sensors in your body that tell you whether you're too hot or too cold. Sometimes those don't work properly. There are times they can be fooled. For example, if you chew gum, the mint in the gum activates the cold sensors on your tongue, and it tells your brain that your tongue is cold when it's really not. It's just been fooled by mint. So if you drink some ice water, it's going to feel very cold to you. The temperature is not any colder than normal. The sensors have been tricked into thinking that it's too cold. Same thing with pepper. Pepper activates the warm or the hot sensors. And so if you eat pepper, you might think it's high temperature. It's really not. It just feels like it is. So if you were to eat a pepper and then eat something that's hot temperature wise, like a cup of tea, it's going to feel a lot hotter to you than normal because the sensors are not working as they should. So they can fail that way by being tricked, or they can fail because they've been injured, or you don't have the right amounts of minerals like calcium and potassium and sodium. If you don't have enough electrolytes, they might not work properly either. Or the targets don't receive the messages. And so the brain can make a message going down to sweat glands, for example. They can get interrupted for some reason. And sometimes the message doesn't reach where it's supposed to reach in the body, at which point it wouldn't activate the appropriate areas of the body. It could be through injury that you have homeostasis disrupted. For example, if you were to have a cut on your hand, blood leaves your body. Homeostasis has been disruptive. You're losing blood, you're losing fluid that your body needs. But if it's a small injury, it's going to be a short-term disruption, and levels go back to normal pretty fast in the body. An illness can change the body chemistry. Certain bacteria can give off toxins, certain chemicals that disrupt the chemistry of the body. So if you have different amounts of chemicals in the body than normal, that will make things change in the body and disrupt homeostasis. Have a vitamin deficiency. If you don't have enough vitamins or minerals in your diet, that will affect homeostasis as well. Did y'all get these down? Okay. Oh, on this slide, you already wrote down the top bullet point. So just write down the next one on here, type 1 diabetes. So type 1 diabetes happens when the body attacks the pancreas. And at that point, when it's attacked, the pancreas can't produce enough insulin. So the pancreas is a gland above your stomach that makes several hormones. And one hormone that it makes is insulin. And in type 1 diabetes, it's been damaged to the point where it can't make insulin like it should. Insulin is a hormone that moves sugar, and this is called glucose, from the blood to the cells. So when you eat something that has sugar in it, that sugar goes into your bloodstream to start with. But it's not useful until that sugar goes into your cells. And so staying in your blood system is not useful for the body. It needs to have sugar move from the blood to the cells for it to be used in the body. And insulin allows it to happen. Insulin is like the key that opens up the cells that let sugar go in. Without insulin, the cells can't take up sugar. So with low insulin levels, you have high blood sugar. You're eating food with sugar in it, and the sugar stays in your blood system and it can't leave and can't be transferred into your cells like it's supposed to. So to treat diabetes, they take insulin shots. So they can move insulin into their blood system, in which case the pancreas can't make insulin, but they can get insulin through medicine, which does the same thing, and they can lower their blood sugar that way. Besides telling the blood sugar to move from the blood to the cells, insulin also tells the liver to store blood sugar as glycogen. On this page, did you get down these 3 bullet points right here? The fourth one will be in the next slide. Okay, so this is the last bullet point on the other slide. Insulin also tells the liver to store blood sugar as glycogen. And this is glycogen right here. Glycogen is a compound made of a lot of glucose molecules. It can be up to 30,000 glucose molecules stuck together. So glycogen is a place where glucose is stored. It's just a long chain of glucose molecules. And then as they're needed in the body, glycogen breaks down, glucose is moved back into the bloodstream. And so this helps regulate blood sugar too. If you have too much blood sugar, it's moved into the liver and stored as glycogen. Too little blood sugar, glucose comes off here and goes back into the bloodstream. So another hormone made by the pancreas, glucagon, tells the liver to break down glycogen into glucose to raise blood sugar. So insulin lowers blood sugar and it moves sugar from the blood to the cells. Glucagon does the opposite. It moves sugar into the blood. So these two work against each other. Insulin and glucagon do opposite things, but they help regulate the blood sugar. If it's too low, glucagon comes in and raises the blood sugar. If it's too high, insulin comes in and lowers the blood sugar. So we talked about type 1 diabetes. Type 2 diabetes is similar, but it has a different reason why it happens. Type 1 diabetes, you're usually born with it. It's usually genetic. Type 2 diabetes, usually you get it later on in life. And it's usually more due to your diet. It can also be partly genetic, but it's more so, it usually happens in late adulthood, middle age, later adulthood. Usually it's not something that happens in your teens or childhood years. But type 1 diabetes, usually you have it from birth and onward. Type 2 diabetes, they're not sure exactly what happens, but what they do know is that the pancreas gets overworked and it can't make enough insulin. And that usually happens if you have a high fat, high sugar diet. So if you eat too much sugar, your pancreas has to get the sugar out of your blood by secreting insulin. And if it's overworked and it has to use a lot of insulin every day, then it can get to the point where insulin doesn't work very well. Either the pancreas can't make enough insulin or the insulin itself just doesn't work anymore. So those are the two reasons why you might get type 2 diabetes. Either the pancreas just can't make enough insulin to keep up with your diet, or the insulin is being made, but it's not working like it's supposed to. And in either case, what happens is you get high blood sugar. Just like you get type 1 diabetes, type 2 diabetes, you also get high blood sugar. And usually it's managed through your diet. Generally with type 2 diabetes, They just have you watch what you eat and make sure that you keep the right sugar levels in your blood. But insulin can also be used, but type 1 diabetes is more often is when you use insulin shots. Type 2 diabetes also, but at the onset of type 2 diabetes, you have to really just watch your diet and try to maintain the right blood sugar levels by watching what you eat. Just to recap what we talked about, with low blood sugar, a signal goes into the pancreas, telling the pancreas to make glucagon. That hormone goes into the liver and makes glycogen break down into glucose, and then glucose goes into the blood to raise the blood sugar. And so that's what happens with the green arrows. With low blood sugar, glucagon comes into the liver, breaks apart glycogen to get glucose. Glucose goes into the blood system. If you have high blood sugar, the pancreas then makes insulin. And insulin makes blood sugar go into the cells and pull sugar out of the blood into the cells. It also goes to the liver and tells the liver to store glucose as glycogen. And so it converts glucose into glycogen in the liver to bring down the levels of glucose in the blood in two ways. So some glucose goes into the blood cells, into the tissue cells. Some sugar goes into glycogen in the liver. And those are two ways it lowers blood sugar. So on this slide, you don't have to draw these, but it is good to understand the main idea behind it. Like just, I would write in these words at least, so you know the process that's happening here. But it just is a recap of what we talked about in the last few slides about what these two hormones do. And the pancreas is right above the stomach. And the liver is right above the stomach too. So these both are right above the stomach. And they secrete digestive enzymes to the stomach to help digest food, as well as secrete hormones to help move sugar out of the blood or into the blood. This right here, you don't have to write down what I'm showing you on here, it's just for your information. But this shows you how type 1 diabetes affects a lot of organs in your body. So with type 1 diabetes, the pancreas is attacked by the immune system and insulin production decreases. The cells can't remove blood or can't remove glucose from the blood very easily. So you get high blood sugar levels. At that point, the kidneys have to move that sugar out of the body. And so they have to move out the sugar with lots of water. And so you lose more water than normal with high blood sugar. The body begins to use fat stored in the tissues as energy. And so it breaks down fat more than it's supposed to. And as fat breaks down, the blood becomes more acidic. So with more acid in the blood and less water in your blood, the cells start to become damaged. And the cells throughout your body don't work properly. Some might die. And this will affect every organ system in your body. Also, the blood sugar will attach itself to your blood cells and into the walls of your blood vessels, which will make them not work as well. This can damage your blood vessels, and it can lead to tissue death. So it's common in diabetes to have blindness occur because the glucose goes into, with sugar, it makes this compound, this tough compound, that sticks to the walls of your blood vessels. And this can then rupture your vessels. And if that happens in your eyes, you lose blood in your eye cells could die, and those don't repair themselves, which could lead to blindness. And so diabetics have to monitor blood sugar levels to make sure that this doesn't happen, because if you get high blood sugar over and over again, that could lead to tissue being damaged or dying. On this slide, you should write down this bullet point right here. But again, you don't have to write down what's on this picture. So if it's a short-term disruption in homeostasis, usually there's not much harm. And so short-term disruption would be, like a small injury that repairs itself, or a cold that you get over in a week. So, for a little bit, levels are not where they're supposed to be if you're sick, but you can get over that in a few days and then you feel better and levels are back to where they're supposed to be. The long-term disruption causes more damage, like diabetes would be a long-term disruption. That's something that happens, for several years or for your life. And that's a more serious thing because levels are constantly out of whack and you have to constantly monitor the levels you have in your body and get them back to where they're supposed to go. Okay, that's it for 28.3. Homework is on page 811. It's questions 1 through 5. And we'll start next week on Monday, go into the chapter review, and we'll review for 3 days next week, have the test on Thursday.